Bert leads an interdisciplinary practice of architects, urban designers, interior designers, landscape architects, and ecologists dedicated to setting new, achievable standards for sustainable design. He's an expert in the development of resource-efficient structures and communities and serves as a national leader, speaker, and advocate for sustainable building and urbanism. With Mithun's offices in Seattle and San Francisco, he has transformed the 60-year-old regional architectural and planning firm into a national, dare I say, international force, inspiring a sustainable world through integrated design. A frequent lecturer and contributor to several books on architecture and design, Bert's design awards include 4 AIA Top 10 Green Projects, 2 ASLA National Honor Awards, and the AIA National Honor Award for Regional and Urban Design. He currently serves on the USGBC LEED ND Core Committee as Vice Chair, and the Urban Land Institute's Climate, Land Use, and Energy Advisory Group, the Washington Governor's Clean Energy Leadership Council, the Clinton Climate Initiative's Climate Positive Programs Technical Resource Group, and he is an advisor to the National Building Museum's Intelligent Cities Initiative.
I'm an architect and urban designer, so a little kind of my day-to-day job is working on projects, and some very interesting projects around the country. And they all have a very important component, which is trying to make a great place. And that's the most important thing first, is elevating the human spirit and making a difference in people's lives. But while we do that, we're certainly very focused on trying to do that in the deepest, greenest way that we can within the constraints of governance and finance. And those are 2 of the largest challenges that we, of course, always face. One common thread I think that you heard among these folks was a word that didn't come up, but a word that is about quality. And I think when we talk about these kinds of things, it's really about this new definition of quality that we're seeking in all these attributes, be it a city or a neighborhood, a building, or our lives. I wanted to talk about a couple of 3 particular topics that are kind of at the edge or emerging forces in design at the moment. The first being eco-districts, the second being continuous technology integration, and then the third thing being following the natural systems model. Now, for many, many years, we worked and really tried to get the buildings right, the green buildings, understanding the importance of that increment within the system. Certainly the exciting venue that's happening now is going beyond the buildings and thinking of neighborhoods, districts, campuses as systems. And they can be ecological systems, they can be water systems, they can be energy systems, they can be human habitat systems. And when we start to think about the spaces between the buildings and the buildings themselves as an interconnected system, there's a tremendous range of opportunity that can happen. And it's a very interesting scale when we think about this neighborhood scale, because we all identify with our neighborhoods. It's a walkable unit. You know, that's where we can walk, hopefully, to get our groceries or our coffee or to a park. And they can be interconnected by mass transit. The optimization of energy systems or water systems at the neighborhood level is really the next threshold. And we see that in Europe very robustly, places like Sweden and Denmark. We will see that transformation start to happen here as we recognize there's too much waste in our system, and we cannot afford to waste energy, energy generated somewhere maybe 500 miles away, that's only being utilized at about 1/3 its unit level, where if we use that energy in a neighborhood, turn that into electricity and capture the waste heat, we can push that to double that, or even more than double the utilization of that energy. So eco-districts are certainly an emerging force, green buildings to green neighborhoods, integrating the public and the private realm, very important when we look at stormwater. Considerations of energy, water, habitat, jobs, housing balance, economics, transportation, the quality of place, social metrics, and health. And many of these eco-districts are coming forward kind of from a neighborhood-based initiative. A neighborhood wants to create an identity Like in my city, Seattle, there's carbon neutral Ballard. And so carbon neutral Ballard is a group of people that are trying to create their neighborhood to be carbon neutral. In Portland, a very interesting initiative of the 5 eco-districts in Portland, which include the Lloyd District, the Lentz District, the South Waterfront, Portland State University, and Gateway. And they're 5 completely different neighborhoods with completely different economic conditions, soil conditions, energy providers. So they will develop their own identity as an eco-district based upon what's important to them. Certainly the 10th Street Corridor project here in DC is a very exciting eco-district initiative. And all these are really tied to some kind of a metrics. And so each of these eco-districts are trying to establish clear, quantifiable metrics so they know what is their goal and then how far do they go to achieve that goal. Another interesting development is really continuous technology integration. And when I was a young architect, I would draw the building and throw it over the fence to the mechanical engineer, and the mechanical engineer would try to stuff the ducts in my building. And sometimes that worked and sometimes that didn't. Well, certainly now with technology, as we look at software and the advancements of software, you know, we can access information really from anywhere around the world about the characteristics of a project in terms of the ecological systems. We can access GIS data in a city and understand all sorts of attributes of that city as we start to design the city. And we can understand the bioclimatic forces on a building or a neighborhood. We can start to model at a very early stage, a clay-like model in the computer. What is the shape? How can we optimize the shape of that building to minimize energy consumption, as an example? We can start to model collections of buildings or campuses or neighborhoods to try to optimize the relationship between these buildings to understand how do we optimize the energy performance. Now, as time goes on, moving that model in an integrated process with your consultants, each consultant can then work on that model and the contractor can work on that model, and we can optimize the building and its cost all the way through the process. That model then can be moved, in some cases, to the city as the permit drawings. And the city holds that model as a computer record of the project. The City of Bellevue, we're creating a city model for the City of Bellevue, which will be integrated with GIS, a 3-dimensional Revit model, in which architects will move their models into that city model. That will be the repository of information for the city. Now, as we move those models and construct the building, that model can also be the operational model for the building. I mean, it can be the intelligent aspects of how control systems work, how the smart meters work, and then ultimately, for the next building I do, I can understand how does that building shade my potential building. So continuous integration of technology is a very, very interesting thing. Tied to that is a very interesting thing that's emerging, which is outcome-based codes, and specifically for energy codes. Typically, we create a model to see how our building will perform, and pretty much we're pretty accurate, but we don't really know how accurate we are. But an emerging trend is outcome-based codes, meaning that the actual certification, final certification of the building, is based upon what does the meter read once the building's done. So that's an emerging, interesting aspect. So the movement from green buildings to green neighborhoods is a very significant emerging movement. I think the third interesting thing, and it's great that we're actually in this space because it's really the natural systems model. And I always tell people that, well, just what we want to do is we want to create a building with a lot of daylight that has high ceilings, that has windows that open, that's composed of as much natural materials, organic materials as possible. Well, okay, you know, they used to do that, and they did that a lot. If we create buildings with a lot of organic or natural materials or earth-based materials, we know that the carbon load of those is going to be traditionally much more less. If we utilize a lot of wood in a building, especially for its structural purposes, we can lock the carbon in a building for many, many, many years. Now, natural systems model, let's say for water, is a very important model. Many codes are establishing a pre-development condition for which then we have to emulate in some way. For instance, Maryland's new regulation requires a 50% pervious area for a site, or you have to create the performance of your system to operate like a 50% pervious surface. And those are very interesting advances in terms of analysis and modeling to try to emulate nature, to try to fix things so that it works like a natural system. We do that for airflow. We certainly want to eliminate fans. You know, hot air rises. All you need to do is just make sure you create a track for that using computer modeling to try to do displacement ventilation, draw that air up out of chimneys in a building to eliminate fans is an important advancement. Biomimicry, of course, that's a very fascinating subject and a lot of things happening there in which trying to create technology that emulates nature in some way. And then finally, biophilia, and that's a E.O. Wilson term about the fact that we all have an affinity toward nature and a very important part of our lives. So a building like this that has these glorious windows that have such a sparkle to them and an interesting color, you know, we respond positively to those kinds of things in our lives. And you can just imagine if this room had no windows, it wouldn't be nearly as nice. So as we look to the future, I think looking at systems-based thinking, meaning beyond the green building to the green neighborhood, thinking about how technology can be our friend in order for us to really understand information. And then the third thing is there's a really good teacher out there, which is nature. We just need to follow that lead.
Great. Thanks, Bert.